Hello, my name is Dima Kovalenko, and this is a presentation on managing a large-scale Selenium grid with multiple data centers and virtualization options. My coworker Jack and I have been working on this project for many months now, and we would like to thank Groupon for encouraging us to explore all the different possibilities and expanding this great open source project and helping it to grow as we go forward. I would also like to say thank you to the guys at the SeleniumCamp. They have been doing a great job in the last couple of years organizing a yearly get-together for people like us to come together and share our ideas and what we've been working on so far. This is Jack. He is a good guy. He is very smart. He is very polite. And he did a lot of the technical work in this presentation. However, he was a little bit shy, and he said that, yes, I will co-present with you as long as I just sit and not talk. Well, Jack, when you give me this much power, I'm gonna abuse it. I'm gonna make you into a pirate. Yeah, Captain Jack Sparrow. That's right, Jack. Remember, don't give people this much power. Yeah, I know. But anyways, Jack is a great guy, and I want to say thank you to him for everything he's done this far. The very first thing I would like to talk about in this presentation is about virtual machines and virtualization in general. Part of the reason we went with virtual machines for the Selenium Grid and all of the build stuff that we were doing is because managing a whole lot of actual physical computers was becoming a little bit out of hand. You can only store so many of the big boxes of older computers on your desktop under your table for only so long before you start to collect very high electricity bills. So we did a lot of research into the different options available. Some were open source, some were paid, some were very nice, some were underdeveloped, but we eventually settled on Zen virtualization. Zen is a open source GNU licensed project. It is free to download, it is free to install. It is great on the point of view from the money alone. The thing about Zen is that it is incredibly lightweight. It is not a big enterprise level solution where you have to have many servers and all of them have to have a certain amount of RAM. Instead, it is a very small, very lightweight application that you install on your computer, and with it you can spin up as many virtual boxes as you have memory to do so. Right now we are running about 8 Windows 7 VMs per one of the Linux boxes, and each one of them takes about 5 seconds to restart if the computer crashes or we need to do any sort of update. This is great if you have something that is unstable as Internet Explorer or Windows itself, because you can restart the computer either after every single build or after every 5 builds, and thus increase your stability several times fold. It is very good for this type of situations. Now, you might ask yourself, why would we install 8 Windows computers on one Linux computer? Doesn't the overhead of having 8 operating systems negate the point of having a very good and fast box that can finish your build in a matter of minutes instead of tens of minutes? Yes, you would be right. However, the problem with using only one computer is that you are stuck with whatever version of the browser or system settings that you need. When you have a virtualization solution, you are able to have as many configurations as you need. So you can have several boxes that are Internet Explorer 8, 9, maybe even sometimes Internet Explorer 5. And the best part is that if you need more Windows IE 10s, then you can spin up 10 more while shutting down a couple of the 8s, and you can have your grid dynamically adjust to the needs that you have. Thing about Zen is that it has been incredibly stable for us. For the last 1.5 years of it running in our production CI, we did not really have any single problems whatsoever. There hasn't been any unexpected crashes. There hasn't been any weirdness. So far, it's been the most stable solution that we've ever run into when it comes to virtualization. Zen is a Linux tool only, so you will be only able to control it through command line shell commands, and they're pretty simple. Basically, you say Zen start, and then you give a computer name, and it figures it out and starts that up. Same goes for shutdown. This is great if you have some cron jobs or some tasks or even Jenkins builds that can get on the box and basically can spin up 3 Windows computers on the fly and then shut them down after the build is done. The minor disadvantage is that you might have to be a little bit of a Linux savvy person to at least set it up. Once you set it up, it's a little bit easier, and you can hand it off to somebody who doesn't have as many Linux skills, or you can write a couple of shell scripts that somebody can execute, and that will take care of everything for you. Since it is a Linux application, what you can do is, once you set up one Windows computer that you like, there's just an image that you can copy and paste as many times as you want, and you are able to update the image and copy paste it 10 times, and all of a sudden you have 10 identical Windows computers that have identical situations, and IP addresses are managed separately and things like that. All of the configuration stuff for each of the Windows computers is stored in a text file. So the computer name, how much memory it has, how much CPU it has, etc. And since it's a text file for the config, you can easily put those text files into Git repository or SVN repository. And what makes it great is that now you are able to basically go back in time for your image and put the same amount of RAM or CPUs that you had 6 months ago, or fast forward through the configurations and give it more RAM. But anytime if you completely mess something up, you will be able to recover it, and that's completely great. So let's take a look at the typical configuration file. It does not look overly intimidating, but there is a little bit of stuff going on. But here's the main parts. Right here you have the name of the computer, and as you can see, we have a naming convention that's basically describes everything you need to know about the computer, and then a incremental number at the end so you know which one to connect to. Right here is your CPU and memory settings that you can tweak on the fly, and double your memory, restart, and all of a sudden you have 8 GB of RAM instead of 4. Side note, we've been using 4 GB of RAM, but we've noticed that if we even take it down to 2 GB of RAM with Windows 7 and we have a single Internet Explorer build running, that the build time does not actually increase much. So we're thinking of maybe trying to running more like 12 Windows computers per the Linux box instead of 8 we have, because it seems that we overestimated how many resources the Windows boxes will need for this. In the end there's the VNC display number, and basically Since all of them are running on the same computer, you need to be able to log in into any of the Windows boxes if you need to do any maintenance, and this is how you separate them out so you can jump in. I'll talk about this more a little bit later. Again, Zen takes care of the networking for you by using Bridge Network, so it takes care of the IPs and everything for you, and at the end of the day, you have only one computer, one Linux computer, and all of the Windows computers, they have their own internal IP, but everything is talking to a single Linux computer instead of having 8 more computers on a network. If you come from a place where adding new items to the resources to the network is very difficult because the system administrators are not as open to the idea of having 200 new computers added at any given time, this is great. However, you can also have each computer join the network as their own separate computer instead of sharing the networking stuff. The GUI access is not the greatest. You will have to use VNC. I would not recommend using Windows RDP because it has some bugs that will make your test unstable. So you will have to use VNC, something like tight VNC. The great thing is Zen will take care of the setup on the server side for you, so all you have to do is just install a VNC client on your computer. And again, as I mentioned before, each computer, each virtual machine is running on a different port. So in this situation, when we're connecting to a single Linux box, all I have to do is just bump up the port, and I just switch from computer to computer quite easily. There are a couple of disadvantages to Zen though. You do need some Linux experience. You will have to figure it out up front, and this might be a couple of days, maybe a week or two before you can get it up and running. There is no GUI way to shut down and bring the machines back up again, so you will have to either do it by hand or write a shell script, or possibly just create a Jenkins job that all it does is starts a virtual machine or shuts it down, and you pass in the parameter of what virtual machine name you want to use. We've been using Jenkins as a GUI access to control this, so it's not that difficult, but again, it's a little bit involved. It doesn't have as many features of VMware. For example, it's not easy to copy and paste some file, either text or file from your machine to the virtual machine. There's no ability to do that. It's not as easy to send files directly into the virtual machine like you can with VMware or other more expensive solutions where you just drag it from your desktop into the virtual machine image and it just appears on a desktop. So you would have to do some sort of a Samba connection to the computer to drop into a new file if you needed to, or maybe store things in version control systems such as Git, or have a shared network drive for files that you want to quickly move back and forth. And again, as I mentioned earlier, it is a lot of work up front, but that kind of makes up for it later on when you can go a year or two without even looking at the system. Next, I'd like to talk about proxies. We have several data centers that are all over the world. We have a data center in Chicago, one in Palo Alto, California, one in Germany, one in Switzerland, one in China, and etc. And we have a lot of resources that are not used in between those places. For example, when people in Germany are working, most of the people in the US are sleeping, and we have all these Windows boxes that are there, but they're not doing anything. So the idea is to share resources across the world depending on a time zone. Well, that becomes a problem when you have multiple data centers. the data centers, all of them have firewalls that prevent each other from easily talking to each other. And this is for a good security reason. But if you wanted to share some network resources, this becomes a problem. So let's take a look at it this way. If you draw a firewall between a data center on the left and a data center on the right, and we throw in a couple of computers, let's say we have a couple of staging and testing environments on the left here in Germany, or you have a couple of Windows boxes in Chicago, they're not doing anything. Well, if we wanted to test with the grid against the staging resources in Germany, we are not able to get through the firewall. So the solution that we decided to take is to set up a simple, the only thing you have to do is in Java is specify what HTTP proxy to use, and the way you would do it is you would put the proxy host and proxy port before using the -jar Selenium jar, and then specifying whether your hub is whether the role is a hub or a node. This way, both the nodes and the hub, they use the proxies, and hub is able to send information to the node. The node is able to execute that command, download the web page or click on the web page, and then pass back all the information from that web page back to the hub, back to the test. So now you have a full loop. Now I'm gonna keep this last section kind of short because I blame Jack for doing too much good stuff on the beginning with the virtualization and proxies. And this last part is a project that I've been working on for about a year now. We called it Selenium Grid Extras. And basically, the goal of the project was to stabilize the operating systems of all the nodes and give you a little bit more control over the Windows resources and Mac resources and Linux resources. After running the Zen machines for a while, we started to realize that if you just let Windows run for a couple of weeks at a time and have about 1,000 builds a week go against it, sooner or later Internet Explorer will crash and it will bring down the whole grid because all the nodes just decided to crash and become unresponsive. There was no easy way for us to control that or fix that, except to add a couple of scripts to restart the operating system either once a day, or try to figure out if Internet Explorer crashed, and if it did, then to go and kill the Internet Explorer.exe, and then kill also the IE driver.exe, which if left behind in a crashed state will just not allow you to keep tests coming in. So the idea of Grid Extras was to tie in into existing default proxy class that exists in the Grid Hub, and specifically tie into the before and after session hook that happens. Basically, when a hub says, I need new Internet Explorer, that we go and we find the computer to run it, and then we can execute some stuff on the computer before the test starts and after the test starts. So in case of, say, using iPhone or Android simulator, we are able to go and we can start up the simulator to make sure it's all up and running first, then let the test execute, and then after the test is done, we can restart the simulator, thus making the stability a lot more. It works something like this, where the after build point is called, and we figure out that the current test was running on Internet Explorer. So then we can send a command from the Grid Hub itself over HTTP to the Grid Extras and say, hey, can you please kill any of the Internet Explorer and IE driver or Chrome driver executables that are left behind. This way we don't have a polluted machine. On top of that, we are able to say, after 10 builds on this computer, why don't we just restart it? This has increased the stability of our grid by more than 90%. Before this, we would have to have at least 1 or 2 weird crashed builds a day, and I would have to go into the Windows computer and restart it and try to fix it. Nowadays, I have not touched those computers in about 8 months. They just get restarted after every build. Again, with the Zen solution, it only takes 5 seconds to restart, so we just restart it, it's happy, and we're back to normal. We added a couple of other things into the hub. We were unhappy with the fact that we cannot easily see what is going on with the nodes that are out there. The console is great, but it does not give you an accurate understanding of what is going on any given node at any given time. So we added a JSON servlet to allow you to consume things and maybe add a little interface or some simple HTML to display how your nodes are doing, whether they're busy or not. This is a rough JSON output from that, and right now it only tells you what computer you have, that's the IP right there, what browser they have and what version of the browser they have, and if the session field is blank, that means the box is completely empty. But if it has, as in it's not running any builds, but if it has a session in there, that means that somebody is currently using the computer, so you can know which nodes are free or not. A couple of features that we been working on is one of them ability to turn on and off the IE protected mode automatically before the build starts. Before the Internet Explorer is launched, we automatically go and modify the registry and turn it on or off depending on what you want. By default, we turn all the settings to 1. This way you're not having any weirdness on Windows Vista and up with the UAC. We are able to tell all the computers to go and update their WebDriver to any given version. So you just make a request saying, hey, I want all 300 of you to upgrade to a newer version. Same goes for Chrome driver and IE driver. We are able to kill any web browser after the build or before the build. And we can check things like if port 444 is busy, or if the port where the Chrome driver is running is busy or not. This way we can kind of check and make sure that everything exited properly when we needed it to. A couple other things, you can restart the operating system. You can take a screenshot of what's going on. That way you have the whole page screenshot. This has been incredibly helpful because there was, for a while, some weird builds where Internet Explorer builds would not be passing and there was no output in Jenkins. After taking the screenshots, it was easy to find that as Internet Explorer would start, a pop-up would come up saying, please update Internet Explorer. And that prevented the test from running in the first place because we were not able to click on it. But at the same time, it gave us just a timeout error without any information saying that I could not connect to Internet Explorer. So this thing has been already useful for us to kind of debug those weird stability issues. There's some other features like ability to see how much RAM a computer is using or how much free disk space it has, and other features that are constantly working on. If you have some features that you would really like to have and have ability to control your grid a little bit better, please help us out. I mean, here's the GitHub URL. You can fork us and send me a pull request, and I will definitely review it and merge it in, especially if it's something that is very, very useful that we have not done yet and haven't thought about it, but will make everybody else's life simpler. So thank you for tuning in to this presentation. My name is Dima Kovalenko. You can reach me at my Twitter handle there. I hope you keep using Selenium and keep getting better and better at it. Thank you.